Alright, this section is going to kind of wrap up our writing equations for lines. We're learning how to do that. We'll continually use that throughout the rest of the year and really the rest of mathematics, but this will be kind of the last formal section in which the information is laid out in front of us. We're talking about point slope. Okay, so point slope form is an alternative way to write y equals mx plus b, or the slope intercept form. And slope intercept form is actually a derivative of point slope form, meaning that y equals mx plus b actually comes from point slope. Okay, so in order to write an equation in point slope form, you need two things. You need a point that is on your line. Okay, and it doesn't matter what that point is. It could be an intercept, it could be an x-intercept, a y-intercept, or just any random point that is on the line. And you need the slope of the line. Okay. Generally speaking, this is the technique you use when you don't know what the y-intercept is. But here is the point slope form formula. Okay. Basically, what we're going to do is we're going to have y and x right in these two spots. They're going to always be y and x. And then y1 and x1 are the point that was on the line. Now it could be an x-intercept, y-intercept, or any other point. Okay, and then this here is your m, which is your slope. Okay, once you have those things and just insert them in here to this format, you have the equation of a line in what we call point slope form. All right. The one thing to know is that what I've highlighted here, they stay y and x. So we have an equation here, okay, and I want you to figure out what this equation is. So first thing we have to know is what the slope is, okay. So they a lot of times won't explicitly tell you that. You have to determine it. So we've got these 2 points, and our slope formula, remember, is the difference in y's over the difference in x's. So I'm going to subtract my y, so 4 minus -3, and then 1 minus -2. So we get 7 over 3. Okay, that's my rise over run. So now if I want to write the equation, I just take this form, y minus y1 equals m times x minus x1, and I plug in my slope, which was 7/3. This x stays x minus. Okay, so now I just got to choose one of these points, and it doesn't matter which one you choose. Let's say I choose that one. X was 1, and the y1. So this is my x1, and this is my y1. So then I have y minus y1, which is 4. That's an equation in slope. Point slope form. Okay. Now your neighbor might have said, well, I'm going to do the same thing, but I'm going to choose this point. Okay, so if I choose that point, it's going to be y minus y1, so minus a -3, becomes +3, minus a negative, equals, m is still 7/3, and now it's x minus a -2, so it becomes +2. That is the equation in point slope form. Okay. Now, what's nice about point slope form is that you can always change it back to slope intercept form. You can always solve for y, because these two things look like they're different. Well, what we can do is I'm going to go y minus 4, distribute my 7/3, so I get 7/3 x minus 7/3, and now I want to solve for y, so add 4 here, add 4 over here. So it becomes y equals 7/3 x. Now negative 7/3 plus 4, well, 4 is the same thing as 12/3. So negative 7/3 plus 12/3, I add the numerators now, and it gives me positive 5/3. So that's my equation in slope intercept form. come over here, do the same thing. Distribute your 7/3. So if y plus 3 is equal to 7/3 x plus 7/3 times 2, just multiply the numerators, so we get 14, and then multiply the denominators, so it gives me 3. Now I'm going to subtract 3 from both sides. Okay, so I get y equals 7/3 x. Now 14/3 minus 3, well, I need to write that 3 as 9/3. It's a 9 there. So 14 minus 9 is still 5. And you see, even though that initially looked different than that, if we go through the algebra and solve both of them for y, they are indeed the exact same thing. Okay? So that tells me that it did not matter whether I chose x1, y1 to be that point or x1, y1 to be that point. It is totally your choice. Something that can help you, especially with these fractions, is to use the Desmos calculator. If you struggle with the adding and subtracting of like this 4 to this 7/3, you can actually type in negative 7/3 plus 4, and it will give you the 5/3 if that's something that you're struggling with. Okay. So one thing that we like to see, or a question that we're commonly given, it says, given the following set of points, determine the line that passes through both. Okay. So essentially it's the same problem, except for instead of giving you the picture, they just give you these 2 points. So same thing we need. Whenever we do this, whenever we find the equation of a line, we need 2 things. We need a point that is on the line, we need the slope of that line. So let's first find the slope here. So slope is, I'm going to write it this way, change in y over change in x. This is called delta. And all that delta means is subtraction. So subtract your y's. So negative 6 minus 4. And then change in x, so subtract your x's. So negative 3 minus 2. So negative 6 minus 4 is negative 10. Negative 3 minus 2 is negative 5. So I get a slope of 2. Now, when I go y minus y1 equals m times x minus x1, it does not matter which one of these I use. I like to use the positive ones here, but it doesn't matter. So I go y minus y1, so there's my y1. That's my x1. And remember that there was our m. So put 2, then x minus x1, which is 2. So in your homework, when it asks you to write an equation in point slope form, this is what it wants. Okay. Now they might ask you then, in addition to that, write it in slope intercept form. Well, slope intercept form just means solve it for y. So I'll have y minus 4. I'll distribute the 2x minus 4. Distribute that and get 2x minus 4. Now I'll add 4 to both sides. Make y equals 2x. Okay, that would be my equation. How can I guarantee that that's true? I'll plug in these values. If x is 2, does it give you y to be that 4? If I plug in x to be negative 3, does it give you y to be that negative 6? So this is indeed a rule that is allowing these points to show up in that relationship to one another. Now, a lot of times the question is, why is this slope intercept form a result of the point slope form? Well, if I do this, and let's say I'm looking at a line that has that y-intercept there. Let's just say, I'm going to say the slope is still just m here, just arbitrary random value of m. But that point right there is, because it's the y-intercept, the x sub 1 value, the x1 that I'm going to plug in right there, is going to be 0 because it's a y-intercept. And the y value is going to be b. Okay, just some arbitrary value. I don't know what it is. It could be 1, could be 2, could be 3, could even be negative. Okay, but it's just b. It's representing all these possible values it could be. So That's x1. That's y1. Plug those things in. I get y minus b is equal to m times x minus 0. Well, that's y minus b. If I distribute here, I get mx, and m times 0 is just 0. So now solve this for y. You get y equals mx plus b. So that there and that there are the same thing. This is just generated when we have a convenient ordered pair for x1 and y1. So that's point slope form and slope intercept form and how they relate to one another. As we move on, another format that we like to talk about is what we call standard form. Okay, standard. Whenever something is identified as standard, that's like the most basic. You know, if I go buy a car and I say I'm gonna buy a standard or stock car, that means it's just the basic. Okay, basic model. So standard means this is the basic kind of format that we're going to see. Okay, standard form is, even though it's the most basic, it's the most kind of formal representation of a line, it's really one that we don't prefer to use a lot because looking at it, you don't necessarily know what the slope is and what intercepts are and all that kind of stuff. Okay, but it's just an alternative way to express the equation of a line. What this allows us to do, the one thing that is different about standard form than the other two, is that it automatically tells me my x-intercepts and y-intercepts, or it does it very quickly. So here's some key terms here. Remember, x-intercept is the x-coordinate of a point where the graph crosses the x-axis. Your y-intercept is the y-coordinate of a point where the graph crosses the y-axis. Okay? So standard form, there's a lot of different textbooks and authors that will say, you know, certain requirements about that number right there having to be positive. So you have to maybe multiply things by negatives and stuff like that to guarantee that that A value is positive. I'm not going to care about that. There's also texts that say that has to be a constant that is non-zero. I don't care about that either. Some textbooks will say that, you know, we need that C to be on the left-hand side with X and Y, and 0 on the right-hand side. They're all okay interpretations of standard form. Basically what I'm looking for is, when we write standard form, is that the A and the B are whole numbers. Okay, so we're going to eliminate fractions, and they're both on the same side. X and Y are on the same side with one another. Okay. But what's nice about this standard form is that when I find an x-intercept, think about an x-intercept. Take a line here, and I want to find that point right there. That's the x-intercept. If I look at that x-intercept, I know automatically, because it's on this horizontal axis right here, I know the y value is 0. And that's critical for what standard form is going to allow us to realize. If I look at my y-intercept, and we've already dealt with a lot of y-intercepts, our x value is 0, and our y value then is some other number. Okay, so that relationship is really nice for us working in standard form, because through substitution then we can find those x-intercepts and y-intercepts very easily. So just an example down here, example 1. This is, what are the x and y-intercepts of the graph of 3x plus 4y equals 24? All right, so if I want to find the x-intercept, 3x plus 4y equals 24. If I want to find the x-intercept, remember the x-intercept is when the y value is 0. So all we're going to do is we're going to substitute that y value of 0 into the equation. And when I do that, I get 4 times 0, which is just 0. So that really goes away. And I'm left with just 3x equals 24. That's really easy to solve for x. And I get x to be 8. So now I've got that point that I know must be on my line. Okay. Now if I want to find the y-intercept, I do the exact same thing. Take 3x plus 4y equals 24. But now if it's a y-intercept, I know x must be 0. Well, if x is 0, then that thing right there is going to disappear. And I'm left with just 4y equals 24. Y must be 6. So I get that. So now, if I wanted to graph this, equation, that's the fastest way of doing it when it's in standard form. I can now graph x being 0, y being 6, and x being 8, and y being 0, and I can graph that line. Okay. Now it would yield the same thing if you would have taken this line and said, okay, well, I know based on what we've already done in previous sections, solve for y. Get 4y by itself, so subtract 3x from both sides, and then divide everything by 4. And I can do that, and that would be okay. That's an equation of this line, and if I would graph that, I'd go up to the 6. That's my y-intercept. I'm going to go up to 6, and now I'm going to go down 3 to the right 4. If I go down 3, 1, 2, 3, it'd be right here, and over 4 would be 1, 2, 3, 4, okay? And then down 3 more, and over 4 would put me at that point eventually anyways. My hope is that you see that if, depending on the format that they give me, we have different techniques that are going to allow you to get the graph efficiently. Alright, so we'll do this another example here. It says, what is the graph of 4x minus 3y equals 12? 4x minus 3y equals 12. So, if I want to find the x-intercept, that's when y is 0. If I want to find the y-intercept, that is when x is 0. So I always write that down, and then I'm going to just, because it tells me what to substitute. So in this first one here, when I find the x-intercept, the y is 0, so I'm going to just have, that's going to go away. And I'm just going to be left with 4x equals 12. So then x has to be 3. Over here, when x is 0, that goes away, so I'm left with negative 3y equals 12. So y equals negative 4. And right there, it's very easy. X to be 3, y 0. Here, x is 0, y is negative 4. Draw your line so those points connect. And we're done. So that's very quick, very easy to get your graphing, okay? Now, throughout the whole process, I never talked about what my slope is, but if I come back to my picture, my slope is to go from one point on my line to another point on my line. So if I go up here 4, so from that point up 4 over 3, my rise is 4, my run is 3, my slope is 4/3, okay, which would be realized if we solve this for y. So if you do need slope, but you're using standard form, once you graph it, maybe you can go between your intercepts and find your slope that way. A couple key things that we like to talk about when dealing with creating equations of lines, writing equations of lines, is parallel and perpendicular lines. So what I'm going to do is free up a little bit of time in class for you to work on open assignments. Along with, I'm going to open up this assignment here for section 2-4, but you're not going to be able to maybe finish all of it because there's some stuff down here with parallel lines, perpendicular lines that I'll discuss with you in the next video. So that'll be coming up soon. So you got like a 20-minute video here, so you got the rest of the time in class to, like I said, finish up any outstanding assignments that are open, and then begin this one.